All right, so we keep going here. As we're talking now, the next kind of little piece talks about then estimation maximum minimum. And it's going to use greatest possible error to do so. So here we have our measurements that's 12 feet by 16 feet. On the low side, if I tell you the measurement's 12 feet, what's the lowest it could be to still be 12 feet and be rounded up? 11.5. And what about the 16 on the low side? 15.5? So on the low side, can someone multiply those two and tell me the area? 11.5 times 15.5. I get 178.25. Little new symbol for you. Have you ever seen this? A square with a line through it. It's another symbol for square feet. Okay? Instead of putting, the letter square feet, you could just do a little box with a line through it. 178.25 on the low side. Let's say we're measuring for carpeting. And the room's about 12 by 16. At the very minimum, you might need to get that. But what if you measured low? On the high side, on the maximum. If someone told you it was 12, what might it be as high as? 12.5 by 16.5. So on the high side, multiply that out. What do you get the area now? A little louder? 206. Exactly? 0.25. And then once again, square feet. So if you're going out to measure carpet, which carpet are you going to pull in? Are you going to order 180 square feet? Or are you going to estimate a little bit on the high side and say, hey, maybe I need to make sure I got the right amount of carpet, get 206 square feet. Okay? So always you're going to estimate probably on the high side. But if someone's giving a different kind of a measurement, it may make sense that your possible area could fall between these two to work stuff out. So just maximum, minimum. You'll see a couple questions like that. Not a big deal. You're just going to go low GPE, high GPE, multiply the two together. Moving down. Percent error. And this is where we kind of pull GPE together with the whole percent of change. If we're talking about the greatest possible percent error, what they want to say is when you measure something, how high is it going to be, how low is it going to be, and what is that percentage? So to start this, here's the simple formula. You're going to have to learn this one. It's percent over 100 equals the GPE over the measurement. So put a little star out to the reminder here because you're going to see this, you're going to need to learn this equation. So let's just kind of fill these in. If the measurement weight is 212 pounds, find the percent error in the measurement. So it's going to be P over 100 equals, now from what we learned on the previous side, 212. What's the GPE on that? What's the greatest possible error on 212? 0.5. Well done, Dylan. 0.5. Divided by the measurement, which is 212. Cross multiply. 212p equals 0.5 times 100. So 212p equals 50. Divide 50 by 212, and what do we get? 0.2358. So that's our percent. Can you have a percent that low? Yeah. It's okay to have a percent that low. Don't change this. Don't change that to 23%. This is 0.23%. Not 1%, it's almost 1/4%. So it's a very low. How accurate is this measurement? If it's plus or minus 0.5? It's pretty good.
So the answer is not 0.23%.
No, the answer is 0.23%. Because remember, by multiplying by 100 here, the key is, Luis, by dividing by 100, we're already in that percent.
Wouldn't it be 2 for 2 for those? Aren't you going to round it?
Yes. Let's round maybe. Good call. I like that. Round it to the 0.24. Nice catch. All right, moving down. Different measurement. 55.3 kilograms. So let's write our formula. P over 100. Help me out here. 55.3 kilograms. What's my GPE now? 0.05. Well done. 0.05 over your measurement, 55.3. You do a lot of calculator work tonight. Times 100. What's 0.05 times 100? Can you do that in your head? Just 5. Divide both sides by 55.3. What do you get P to be? What's your percentage? 0.0904. So our percentage to the nearest hundredth, 0.09%. Basically, that's about 1/10%. Which is more accurate? Example 7 or example 6? Example 7 is a more accurate measurement because they measure to the nearest tenth, not the nearest pound. So it all depends on how we go through there as we're working it out.